Hi everyone, my name's Connor with PIXERA. Welcome to our LA office. I'm here with my friends Cody and Sam.
Hi, I'm Cody, a Technical Solutions Specialist here at PIXERA.
Hi, my name is Sam Slade, and I'm a partner at Astra Production Group.
We're here today to showcase a couple of new features inside of PIXERA. We'd like to show you Unreal Sidecar, the Astra Color Toolkit, and using PIXERA Control as a supplemental control interface for Unreal blueprints. We have a system set up in our lab with two PIXERA render nodes, one responsible for the right half of the wall, one responsible for the left half of the wall, synced together and being controlled by both a PIXERA director unit and an Unreal Engine editor unit. In addition to those two control PCs, we have a third PIXERA Mini running Astra Color Toolkit, which can be used to live color grade content inside the Unreal scene via the network. PIXERA is an easy-to-use, easy-to-manage video and real-time rendering solution. We've developed a texture sharing mechanism to be able to bring that stable, reliable, synchronized playback of video into an Unreal scene. Behind me, you will see the typical end display template scene running on our LED wall with a video in the middle. Now that video is in fact a Notch LC encoded UHD video, which has been assigned to a mesh inside the Unreal scene as a render target. In addition to the video in the foreground, we can also easily add things like a skybox using a single texture that spans the entire sky, as well as using PIXERA Control to trigger animations inside of the Unreal scene. For our customers who use Unreal and nDisplay as their in-camera VFX virtual production solution, we're excited to add reliable, stable, and synchronized plate management into their workflow. In addition to simple timeline, queue, and layer management that's native to PIXERA, we also have an open framework when it comes to implementing GLSL shaders on the timeline. Shaders can have custom parameters, and those parameters can be set via the network from external software like Astra Color Toolkit. To tell you a little bit more about Astra Color Toolkit, I'd like to invite Sam to give you a run-through of their solution.
So I'm going to give you a quick demo of the Astra Color Toolkit. So right now we have this video plate going to this texture on a screen in front of us. And what I can do is you can see here in our toolkit, which is a set of GLSL shaders that are loaded into PIXERA and then applied as effects onto layers that you would like to control. Once those effects are applied, they will automatically populate and be found here inside of this UI. This UI is actually being run on a different machine that's on the network, and we are connecting to the director PIXERA machine and controlling it via this UI. So by selecting our Unreal texture sharing layer, you can see we have a lift, gamma, and gain shader applied to it. So now I can take, let's just say we want to tint nice magenta. We can do that. So we have full lift, gamma, gain control. So typically maybe we'll add a little bit of contrast to it. And we'll add some saturation. Something like that looks pretty nice. We wanted to create this tool because there were so many times being on virtual production sets where we needed more advanced color correction. And being able to integrate with PIXERA was really, really easy and was a no-brainer.
One of the critical elements of our texture sharing mechanism with Unreal is the ability to send alpha with the video. To show you how you can bring transparency in with your videos from PIXERA to Unreal, I'd like to invite Cody to dive a little deeper.
Hi, so in order to look at this alpha, what we have currently is no alpha being shown, and that's using a layer that has a fully white mask. If I hide this, you're not going to see any obvious alpha changes yet, and that's because the background is black. If Sam will press the button to increase the screen size, you'll see that this texture now is showing over more of the Unreal scene, and so you can see through it into the areas of the clouds, of the other materials. And this is being done using a GLSL shader in PIXERA, and on the timeline I can change these values in order to change how this shader is working. I can increase how much is going to be taken away in the alpha. I can switch the type of alpha. So instead of a straight black and white, I can do more of a gradient. Or I can bring back the ability to not have any alpha shown. And this is all being done in real time in PIXERA on the timeline.
When it comes to video resolution, we can achieve the upper limit of what's possible as a render target in Unreal. The driving plate behind me is a 12,000 pixel wide by 6,000 pixel tall Notch LC encoded video that's been scaled down to 6,000 pixels wide to fit within the limit of Unreal. You can see that the video is playing back stably, reliably, and in sync across two nodes, and there's a crossfade between the front perspective and the back perspective. We can swap around quickly and easily in PIXERA, adding new layers, new content, or jumping to different points in the timeline, and you'll see those changes take effect in real time in your Unreal project. In addition to using PIXERA's render engine and timeline to manage video playback inside of Unreal, we're excited to bring PIXERA Control's easy-to-build web UI, extensive Lua scripting, and driver module library as a supplemental front end to Unreal's blueprints. To show you a little bit more about that, I'd throw it back to Sam.
As you can see, we're here in Unreal, and we have two different custom blueprints that are in our level. One is our sequence controller, which we're using to drive sequences and sync them between PIXERA and Unreal. We also have a PIXERA object controller. In here, there's an array where you can add in actors from your scene. So here we could go through and choose something else to add to our level. Currently, I have our PIXERA screen, and I also have a couple of cubes, our light, and also our end display actor. You can see coming back into the PIXERA UI, we have a folder here that has all of those objects populated. And by clicking refresh, it'll check the project and see if any new assets have been added, and we'll add them to this list. By clicking on something in this list, like the PIXERA small screen or PIXERA end display, you can see it changes the target name over here of the object that we're controlling. So I'll go back and select the PIXERA small screen, and then we can then come over here to our position, and we can move our position on our X-plane within our world. While you can do this already through multi-user, having the ability to have this parameter exposed and be able to use other pieces of data to drive it within control shows how powerful it can be. We also have the ability to control lighting in our scene, so every single light in the scene will also be pulled at begin event play, and will show up here in this list. And by clicking on one of these lights, which in this case is our sunlight, we can actually use the color picker inside of PIXERA to select the color of our sunlight, and we can also change its intensity. So in addition to sending data to Unreal, we can also receive data back from Unreal. So for example, I'll click on this PIXERA small screen here. We can say get current object position and rotation, and that will go and grab the current position of the object within Unreal, which we can then use as a relative offset for our translation here. So it'll take the current values from Unreal, and then we will just add the value here. So we don't have to, if we have an object that's really far off in world space, we can compensate for that. Something else you could do, for example, is move cues between Unreal and PIXERA. So if you have markers within a sequence inside of Unreal, you're able to pull those markers into PIXERA and lay them out as cues on your timeline. So you can timeline your PIXERA content to something that has already been programmed in Unreal. You could also go the opposite direction and take cues that have been created in PIXERA and then pass them along to Unreal. So your Unreal artist can now see the cues that you have existing in PIXERA and can match their animations to what has already been timelined. So we also wanted the ability to sync the PIXERA timeline to sequences that are playing back in Unreal. So our main timeline is connected to a sequencer that is controlling the 3 cubes at the front of the screen. So you can see as we're scrubbing through in PIXERA, we're actually scrubbing the frames inside of Unreal. You have to make sure that your sequences are both at the same frame rate, because it's taking the current frame rate of the PIXERA timeline and then converting it to the frame rate inside of Unreal. If the frame rates are not the same, you may get your objects jumping to a different position once you pause. So in addition to being able to play and pause your sequences with your PIXERA timeline, you can also set your sequences to loop. That's an action that is exposed inside of the module. And then there is also a stop loop, so you can stop the timeline and reset it back to the 0 position. So you can also add multiple Unreal sequences into a single controller. So you can see here we have this cube sequence here in index 0. In index 1, if I add the pyramid sequence and then we replay the timeline, so just play and pause, you can see that now both of our sequences are playing in sync with each other. If we no longer want the pyramid in this part of the sequence, we can unload it, and it'll finish its translation and now just our cubes will be playing. If we go to our second timeline here, our Unreal timeline, this one is attached to our pyramid sequence. You can see here we have a second PIXERA index sequence controller, and we have an index of 2 selected, which corresponds to the second instance of the module that we have inside of control. So now we have a second timeline that is driving our pyramid, while our cubes are still being driven by the first timeline. So you can have any combination of PIXERA and Unreal sequences in transport.
Using PIXERA as a virtual media server inside of Unreal brings support for Notch LC, HAP, HAP-Q, ProRes, H.264, H.265, a variety of uncompressed image sequence formats, not to mention real-time notch blocks, NDI, and other video streaming over IP protocols to the table as options for rendering inside of Unreal. We hope that by combining the powerful, easy to use, and stable stream management of PIXERA to the real-time photorealistic 3D world building of Unreal, we'll unlock new and novel workflows for you and your team. Thanks so much for watching, and thanks so much to the PIXERA and Astra teams who were instrumental in putting this demo together. We look forward to hearing from you at our Discord, which you can register for here on this QR code.